Well, good to see a good crowd here today, and it's great to have Tommy here because it was more of a process than it should have been to get you here, but you're here, and so I'm sure you're getting introduced out in the countryside. Excuse me, there's the fall cold going here, but I didn't know how well you were introduced on campus here, so anyway, we're really pleased to have you here. A reminder that this is a cooperative effort between our Institute for Digital Ag and Advanced Systems, Digital Forestry, and Plant Sciences. And so we'll have a little time for questions. Make sure you leave a little time. If you could.
Yeah, the grad students are all saying good luck with that one. So.
Oh, yeah, they know what you're talking about.
Yes, exactly right. So we'll see.
Okay. And before I forget it, I was looking through some stuff on my shelf recently, and anyone recognize this book that was produced 24 years ago? And this is called Precision Farming Profitability. It was developed at Purdue here. It was a joint effort of Case IH and New Holland, CNHI. And in here is a section on precision weed control. And so I know you got lots of new stuff for us today, Tommy, but some of the stuff has been around for quite a while too, so.
Oh yeah, definitely. I always like to say that, agriculture has changed a lot in 100 years, but the one thing that hasn't is that the farmer has many problems. So not everything's changed in 100 years.
And there'll be new stuff tomorrow too.
That's right, 100%.
Okay, thanks again. I'll let you take it away.
Sounds good. Well, thanks, Bruce. Appreciate it. So first and foremost today, thank you all for being here. I just want to let you know in advance. So my presentation today is kind of a hodgepodge of different things. But mainly what I wanted to do is highlight a handful of new technologies in the weed management world that we're either exploring on a research side or exploring commercially for trying to more precisely manage weeds. So some of the things I'm going to talk about today, we do have some ongoing research with. Some of the things are just really cool tools that I wanted to talk about that maybe in the future we can do some research with. And then I'm going to get into a little bit on the extension and teaching side as well, some opportunities there for digital ag and precision strategies as well. So the first thing I did want to hit on though is just a little bit about me. So I am new to Purdue. I just started in April, so y'all may not know me super well yet. So I wanted to at least give you a little bit of background information. I'm originally from the bustling metropolis of Browntown, Wisconsin. Population, what do we have? 262 when I looked it up. Bustling. All right. I grew up and worked on small dairy farms, obviously Wisconsin, right? So it gets to milk cows every day and do some small grain crops, things like that. From there, I went to the UW-Platteville for my undergrad, completed that Bachelor of Science in 2012. From there, I went to the University of Wisconsin-Madison to complete my Master of Science degree. As you can see, I was very well traveled through most of my life there up until that point. From there, I actually went out to Nebraska to do my PhD, and it was in Western Nebraska that I was based on a research station. So I got a little bit of the arid culture out there, dry land agriculture, which was pretty fun. And then from there, I actually had a position down at the University of Arkansas, where I was an assistant and then actually promoted to associate level as a faculty member there. I was in Arkansas about 5.5 years or so. I got to work in soybeans and rice down there, which was a pretty fun crop to do something different in as well. So Arkansas agriculture, quite a bit different than Midwest. But then from there, just this year, I was actually able to join the ranks here at Purdue. And so I started in April, been here about 6 months. I'm learning all the ins and outs of the Purdue Boilermaker system. Fun stuff. All right. I'd also be remiss if I did not mention the family. All right, so I like to show pictures of the cute kids. That earns me some brownie points normally at the beginning of a presentation. So I've got my wife Liberty that's here in West Lafayette with me, as well as my 2 little kiddos right now, Brooker and Brinley. Soon to have a third actually this fall. So fun stuff. Fun. Now, just a little bit of background as far as why precision weed management is kind of taking the forefront across the industry. We have some seriously problematic weeds in multiple different areas. Here in Indiana, I have a few just posted up here as pictures. So this is actually water hemp. It's supposed to be a soybean field, but if you can find a soybean, I'll give you $1. Okay, I'm not sure we can find the soybeans in that water hemp field. Giant ragweed is a big concern for us, a little bit of velvet leaf mixed in there. And burr cucumber, we've been getting a lot more calls on as well that can make harvest very troublesome with weed management and things like that. And then I also like to highlight that these weeds are highly adaptable and can basically grow anywhere they want, right? So this is actually in downtown Des Moines, Iowa, where I took that picture. And we had water hemp that was growing and thriving in the middle of a bustling town like Des Moines. So we need some alternative strategies to help manage these things, particularly because herbicide resistance is becoming a big problem. Everybody loves this video that I like to show, but I don't have a better way to describe the battle that we're dealing with resistance other than this video. It's one of the best ways I can possibly describe it. I apologize in advance. It is Arkansas football, right? I was down there for a few years. But I like to highlight this because this is what we're dealing with out there with resistance and weeds. So pigweed as our example, we've got him charging up through there and we're throwing all of these different herbicides at it to try and stop it. And it just keeps on a chucking, going to the end zone to reproduce, have more seed, and we have to deal with it year in and year out, right? We're just not stopping it. Okay? So we need some alternative strategies, and precision weed management is a big opportunity to help try and manage some of these weeds that just keep on moving. So that being said, kind of the first part of this that I wanted to get into is just a few of the new tools that are maybe available out there that you might not have heard of on the precision weed management front, and then briefly discuss a few different research topics that either the weed science team here at Purdue has been doing or some of the things I've done in my past, and then hopefully some future directions as well. So one of those things happens to be the See and Spray technology from John Deere that is commercially available right now. Okay, thank you, Marcelo, for driving the tractor in this. It's pretty good. All right, what See and Spray technology is it allows in live real time for the system using vision guided, camera guided systems to detect weeds as it's going through the field. It sends signals right on the system to then automatically spray those weeds as it goes across the field. So it's live processing. It's been so far pretty accurate, can detect weeds down to about 1 centimeter in size. And the speed is really honestly pretty promising. Right now, the John Deere is recommending we can go anywhere between 12 and 15 miles an hour with the commercial sprayer speed, which is honestly really quite good for something like this where you have to make as many decisions in such a short amount of time as this kind of system has to do. So this is just kind of an image of what it's doing. It's picking out all those different weeds. It sends a signal to the sprayer to say, I need to turn on and spray at those points, right? So the reason this could be a benefit is for multiple standpoints. But one, these kinds of targeted application systems have the potential for reductions in total herbicides used, okay? And that can help us, one, to maybe reduce any environmental contamination or satisfy some regulatory requirements moving forward. It also hopefully can help our growers out at the end of the day on their bottom line by reducing some herbicide usage and saving on input costs. So there's some opportunities there. Hopefully also it can increase weed control and whole farm efficiency from a few different standpoints. Potentially we maybe have less time required for sprayer fill-ups since we're not broadcasting an entire field. We're not using the same amount of total spray solution. We can cover a few more acres. Excuse me. And then also maybe through less chemical flowing through the nozzles, we have a little bit longer lifespan of nozzles and other spray equipment parts that our equipment can make it a little bit longer as well. So there's a lot of different reasons for us to try and approach this targeted spray habit. Now, just a few results from this system I wanted to highlight. Again, this is from Mr. Marcelo Zimmer back there in the background conducting some of this research. And Dr. Brian Young has had some funded projects through various organizations like the Indiana Soybean Alliance to conduct some of this research to find if this tool, one, is feasible and also usable for a lot of our growers out there. So just some initial results that I wanted to help point out is on the left here, you'll see the broadcast application. On the right, you'll see the targeted application. This left figure was herbicide savings, and this right figure in spray solution, I should say, not in dollars, in spray solution. And this right is soybean injury, because hopefully we can reduce some soybean injury potential if we're applying chemicals that might be somewhat hazardous to the crop. And basically the main conclusion is that as you can see, if we do the targeted application versus a standard broadcast, we did see some spray volume savings, and we also reduced our herbicide injury across the trial area by targeting rather than just broadcasting. Now the picture down here, sorry about the picture being a little blurry too, but you can generally see the glyphosate control where we had Roundup Ready soybean completely uninjured by that application. If we spray something like Lactofen or Cobra, which can be an effective herbicide tool, but you can see it's pretty hard on soybeans, right? It burns them back quite a bit. If we can go to that targeted approach, those soybeans look a whole lot healthier and just have a lot more spottiness to them, that hopefully we can have some opportunities there to reduce that crop injury, reduce concerns for consultants and growers. The other thing that this does is maybe opens the door for utilizing herbicides that normally aren't useful in our different cropping system scenarios, because we would effectively kill the entire crop, right? If we can make sure that we're using very targeted approaches, we can open up the door and have some more options for herbicide rotations and things. Now, I also wanted to mention John Deere See and Spray is not the only vision guided sprayer on the market. This is another one that we're working with here at Purdue. I know Dr. Christian Cruz is up here up front. He's also doing some work with them as well. So this is a robotic, all autonomous system that's right here in Indiana, where it's vision guided. Once again, kind of like the See and Spray, it finds the weeds, sends a signal, turns on to spray just where those weeds are at. Okay. Now, we did a little bit of research this year, just looking at the potential for one, identifying those individual weed species out there, the ability for it to turn on, and then what kind of coverage it looked like around those individual weeds. So you can see that right here, where we had a couple different species. This was water hemp. This was a morning glory. We had coverage cards stacked around it just to see if we were hitting the entire target, what kind of coverage it looked like. And then also based on the nozzles that they selected for this, what kind of droplet size is actually, hitting that target, whether that's an effective droplet size or whether we needed to have some more discussions on setting up the sprayer in certain aspects to maximize effectiveness. The other thing that I love about this video that I wanted to highlight is, does everyone see the strip in the field right there? That was on purpose, okay? Not saying it was a good purpose, but it was on purpose, okay? What they did was, this year they wanted to leave a strip where they applied no pre-emergence residual herbicide and wanted to rely solely on the robot from this targeted approach to see if they could have more savings without having to use residuals up front. What you'll notice is this circles back around. The thing I want to highlight with these targeted applications or any of these precision weed management strategies, it does not get us away from using other strategies. The precision agricultural tools for weed management are just another tool, another cog that we can implement, but we still have to do a lot of our other things together with it. So whether that be using pre-emergence residual herbicides like was used here, and you can more selectively apply because you don't have near as many weeds up, or using things like cover crops to help suppress a lot of the weeds back and then use this kind of technology to go over the top later on. Or various other aspects, but it's not an end-all be-all solution. We have to implement it with other strategies to really truly be successful long-term on the weed management side of things. Okay. I just like that. I like to highlight that with that video. It's pretty effective for that. So that's the Sol and F-Tech robotic side of things, the autonomous. A few other tools that we don't have current ongoing research with, but that are starting to make some waves in the weed science industry that I think could be some potential future options. One is the laser weeder. So this is currently commercially available mainly for vegetable and fruit productions, but it is again vision guided. So they have camera systems on there to detect the weeds. It sends a signal to emit a laser pulse to control weeds. So that's what you can see here. That's the laser actually hitting a weed. That's after the laser destroyed the meristem. And so this could maybe be a great alternative option moving forward from this precision agriculture approach that gets away from herbicides too, right? Again, having more tools in the toolbox, even with precision agriculture, is what's going to be important from a long-term standpoint. So being able to use an alternative approach could be really beneficial in that aspect. And there has been some research in the Northeast with this system so far, and some of the reports I've been told is it actually is working really well. It does struggle with some bigger weeds, and it's a fairly slow process. So this machine, I think, travels up to 3 miles an hour right? Versus our 12 to 15 with a John Deere See and Spray. So limitations, but again, we're laying the foundation to hopefully make it there in just a few years with some of these technologies. I will also say this is extremely expensive right now. I inquired about trying to get one for research purposes at the university. $1.5 million. And then it's also a $20,000 subscription fee every year for the software license. That's mandatory. You can't just like upgrade every 5 years or something, because I asked that question. It's an every year mandated subscription fee. So right now, very expensive. But on the positive side, we talked about the See and Spray, we talked about Solon Tech, we talked about the laser weeder. There are a lot of startups, a lot of venture-based companies right now that hopefully can start driving down some of these costs as we move forward, because there's a lot of interest in this area in agriculture. Now, not only do we have lasers and spraying systems, we also have some precision tillage pieces of equipment. Again, right now it's really heavily focused in the vegetable market. But again, these tools use some vision-guided systems to detect crop rows and basically can till anywhere and everywhere in between the crop as it's moving through the rows. There are some row crop-based precision tillage tools. So the horse transformer tool is a really nifty camera-guided system that basically, it's not looking for weeds, it's simply looking for crop. And as long as it IDs that crop row, it moves its tillage tines in and out to get as close as possible to that crop row. So we're not removing crop and costing us yield, but it can eliminate as much as possible in between. So we're making sure to reduce as many weeds as possible growing through there in an in-row cultivation standpoint. It also helps on the headlands when we reach those, because it can actually pick up the tines based on kind of an overlap sensor, like we already do on precision planters. But then it makes sure that we're tilling the entire area that we need to, but we're not pulling out our crop as well and reducing yield because we just eliminated some of our crop. So that's pretty cool, neat tool. Also, there's a tool based out of Australia, maybe a little bit less effective for Indiana, but still kind of cool to talk about. It's called the Australian Weed Chipper. And basically what it is again, camera guided. You can see what the field looked like beforehand. They're dealing with a major problem of wild radish, which has a big, tap root that they're trying to remove. And so what they do is when the system goes over it, it sends down this whole, see it right there, the whole plow shank to basically just rip out that plant, and it just keeps driving through the field. So this is the beforehand, this is the after photo, where they didn't have to till the entire area, but they could just chip out where all of those weeds were at. Possibly an option where maybe we need to try and maintain some more minimal tillage options or other various things. Okay. Yeah, not a broad scale solution, but possibly in some areas it would have a fit. So lots of potential tools.
I assume I can program these. So if I could be, let's say, young corn, soybeans, rice, whatever. I assume this is not a single crop. Or we haven't gotten that far yet. I took the tillage. That tillage is a good example.
So the tillage one, like for this one here, right? It's basically, it's just looking for any kind of row. So it's not necessarily crop specific per se. This one is all before crop. This one can't handle if there's a crop in there. It's a pre-crop thing. If we're talking, say, the John Deere See and Spray, that is very crop specific. So they have specific models that you can use that in corn. There's a model for corn, there's a model for soybean, there's a model for cotton, which is very handy for Indiana. And then there's a model for fallow, and that's it. So you couldn't use it in any other crop, technically, then, right? The Solon Tech right now, they are basically kind of corn and soybean. They're looking at it in some other crops as well, but mainly it's corn and soybean right now. So it depends on the technology. The laser weeder, I'm not exactly sure how that one's going, but it depends on each system. Each one is kind of unique. That's a good question, Fred. Thank you. Okay. Feel free to ask any questions as we go throughout too. I'd rather have a discussion. I'm good with that. So please feel free to ask questions as we go.
So a follow-up question, like in terms of accuracy, what platform do you think would be the most accurate at the moment for controlling?
Like between specific models for crops?
Models, companies, or that you have tested. I don't know if you have tested some of those.
So that's a great question. So the question was, what's kind of the most accurate, right, as far as the different systems that we've had? I mean, I would honestly say from the ones that I've tested and talked with and stuff, if we're talking precision removal of weeds, the John Deere See and Spray is probably, if not at the top, near the top. But they've been working on that system since, 2016 or before. And machine learning is all about feeding images, right? The more images you feed through it, the better it can learn, the more it better understands that stuff. They have fed tens of millions of images through their system at this point, that they have trained those models really highly effectively. They've also kind of developed a hierarchical structure at how it makes decisions, which has become really effective at basically deciding whether something is a weed, whether something is a crop, and going forward that way. So I would say if we wanted the absolute highest accuracy and precision right now, that one seems to be top of the line. Now, if you wanted a little bit broader scale, like I think this is a really nifty tool that can be used kind of across the board because it's not as precise, right? It's more just let's find the crop row and we'll eliminate everything else out in between. If that's kind of the goal, that is a really effective tool at that aspect. So it depends a little bit on your objective or goal, but that's kind of where I would say things shake out a little bit. Yeah, good question. All right. From there, are there any questions on some of those new tools or research, opportunities, things like that? All right. The next thing I wanted to move into a little bit was talking about imagery and drones and using some of that technology for either detecting herbicide injury or crop injury from various weed management related strategies, or also trying to detect weeds and set up some targeted approaches. Okay. So the first and foremost thing that I've got on here is actually not even dealing with drones, but I figured I needed to highlight it, is there are actually proximal sensing techniques that we can use in the weed management world. We did this with a study just a couple years ago where we used plants in the greenhouse and conducted a digital imagery analysis with it. Okay. If you listened to Lee Miller give a talk a few weeks ago at all, he talked about using turf analyzer. This is very similar. It's field analyzer. It's kind of the same company, but it's based more for kind of the field crop side of things. But basically this program, we're able to take pictures, and as long as those pictures are based from a fixed height and it's standard across the board, the area that you're imaging can be the same, and you eliminate out the hues and saturation of pixels that aren't what you're targeting, right? So this was the before picture that I uploaded in the system. This is after I eliminated everything in the background. And then it gives you an estimate of what the canopy coverage is based on those pixels, or kind of a rough size of that plant. So here, when I didn't factor anything out, the result was 100%, because obviously it's factoring in everything. Once I started eliminating everything, it basically told me that the soybean plant is taking up about 30% of that image, roughly speaking. Now, the way you can use that is you can start making some comparisons with non-treated controls and growth patterns over time with various treatments. So that's exactly what we did over here. So this is the canopy coverage reduction percentage. So basically we did a drift study out in the field, and we had live plant samples to evaluate herbicide drift and the impact on the plant. So we had a plant at each one of these downwind stations. We took these pictures at 4 weeks after application, and we basically just did a % reduction in canopy coverage from our non-treated controls that were able to grow the entire time without any exposure to herbicides. And you can see we were able to fit a couple really excellent curves to that data on estimating that growth pattern and the effect of herbicide injury at those various stages. So the black line was actually from an aerial application. The blue line was from a ground application. And so we were able to get solid, useful quantitative data rather than just visual observational data to use and estimate how that herbicide was affecting our crop. Okay. Now, we also can do some of this from a remote sensing standpoint, using drones and other aerial observational tools, satellite imagery, things like that. So this was a study we conducted down in Arkansas just in the past year or two. And we were looking at herbicide, a new herbicide that was being registered for use in rice, and we wanted to look at the crop injury potential from it. So we had our field study set up. Once again, we're using field analyzer. And it's a nifty program when it comes to a field research trial, because basically you can draw in your grid of plots. remove the borders if you have any borders and things like that. Again, you do the same system of eliminating any of the background just so you get down to the crop that you actually want to evaluate. And it'll give you an estimate then of that canopy coverage or potential loss due to herbicide injury. So on the left again, 100% coverage. If we look at here, I've got plot 101 highlighted. That is saying, that's tough to read. I think it's about a 54% canopy coverage estimate with that plot. And all at one time, you can spit out all of the data for your entire trial for canopy coverage estimates. And once again, we are able to use that data over here in the publication to provide estimates of those various treatments and what level of canopy coverage we had over time. And so you'll notice this treatment right here that basically wiped out the rice. We had a drastic, really delay in what that canopy coverage looked like, because it did eventually catch up. But you can see, again, quantitatively, rather than just qualitatively, some numbers to looking at these various injury symptoms that were out there from the herbicide. Now, I like to highlight, this is a little bit different than if you listened to Dr. John Jin last week talk about his precision sensors on the ground, right? I think like what the discussion got to at the very end was a really useful discussion, is there's room for both of those technologies in our weed science world right now. This is a really, to me, and we're going to get into a little bit more of the remote sensing side, but this is a great way to get a better spatial representation of what's happening in the weed science world, whether it's weeds or herbicide injury or other things. But it can't really tell us a whole lot of specifics about it, right? Gets us a rough idea. We can, a consultant could go talk to their grower and say, yeah, we're seeing some significant hotspot injury symptoms out here. Your canopy coverage might be reduced by that much, etc. But if you really want a precise answer, then you need to go and do some individual plants, those more high-tech sensors that Dr. John Jin was talking about, things like that. But this is kind of a nice starting point to lead in to give him more direction on the specific side, I think. So we kind of go hand in hand together, I think, for a lot of that stuff. All right. So both of those things were with the Field Analyzer program, which is really a relatively base program. It's all run in Java. It's pretty simplified. There's also a program called Pix4D, which we're running some tests with now to get into a whole lot more specifics and look at a lot of different index values to try and maybe get a little bit more precise than what we were just talking about. We'll never be as precise as some of those individual sensors, but if we can find some different index values that get us a better answer, again, the more accurate we can be with a system such as a drone like this that really takes a minimal amount of time to fly, and we have a lot of growers and consultants that are interested in this kind of technology from a speed standpoint, we can find some ways to make it more usable, everyone will be better off. So just a couple images from some studies this year. This is corn at about, I want to say the V5 or V6 stage. And so you can see from an RGB image, there's not a whole lot really that we can detect when we start looking at all those crop rows in there. If we start breaking it down into different sensors, though, this was actually using a thermal sensor on one of the new Mavic 3 thermal drones. And we start eliminating out some of the background noise. You can see the crop rows a whole lot easier. And in this system, you can actually draw out every single plot, like you see here, to then spit out values spatially for each plot on what that is looking like as far as treatment effects. Okay. Now you can drill down into other different indexes. This index right here is called an MCARI index, which is basically a chlorophyll absorption type estimation. And this one has been really useful, I think, at least in my initial tests, where you can drill down and eliminate a lot of the different noise out there, like the weeds and things like that, and get down to just those crop rows. And again, each one of these plots is a different treatment, and you can start to see where some of these have a little bit higher chlorophyll, some of these have a little bit lower chlorophyll. There's those small, minute differences within those corn rows start to pop a little bit more with some of these various indexes. And if we actually put the numbers to it, show a graph, sorry, Fred, I know you don't like looking at graphs, but I'm going to throw up here a little bit at least.
I'll train you yet.
Yeah, that's right. You can see here that when we looked at those images and we pull them in here, you can start seeing some of these trends with the different treatments where on the NDVI side of things, we've got the ones that are higher and greener and more healthy versus the treatments where we started losing some of our NDVI and they were potentially more crop injured. We can also see basically the inverse reaction on the thermal front, which makes a little bit of sense that stressed plants are going to be a little bit hotter than non-stressed plants. And then here's that MCARI one, which even kind of, again, not by a lot, but thinned out some of the errors just a little bit. And we were able to get just a little bit clearer picture, but it matches very nicely with the NDVI graph. And this is actually Jada's project back there that I was just piggybacking off of. And so we had some discussions about which treatments here were falling at the bottom of these. They lined up with a lot of her visual injury ratings where there's about 3 certain herbicides or adjuvants mixed in that were causing issues. And this gave us a nice pattern or trend, again, quantitatively, to say, yeah, those herbicides or those adjuvants are the ones causing the most injury with this specific herbicide that we were testing. I think someone had a question,
So
sorry.
this for X4D, is it only for corn or is it going to work effectively for other crop?
It can work effectively for just about anything. So actually, next slide, soybeans. Yeah, good question though. So Pix4D is really effective across the board. I actually hope to do some work with Steve Myers and his horticulture weed science group to maybe test it in some of the different hort crops as well for picking up various things. But in effect, what it is it's that software is just as good as whatever imagery you're collecting. So if you collect thermal imaging, it can handle that. If you collect the multispectral imaging, which is where that MCARI came from or NDVI came from, it handles that. It can handle just RGB imagery, but each one of those will tell you a different thing. So the Pix4D software can handle basically just whatever imagery that you're going to feed into it. And it gives you answers based off of the resolution on that. Yeah, it's a good question. Excuse me. So I did want to just give an example of a soybean trial too. Here on the left is just the RGB image. Here on the right is where we calculated out the MCARI again. And just what I like to point out is if you look at this RGB image, you really can't see a whole lot that's going on, especially with soybeans that are at about the V1 or V2 stage, right? And also you'll notice here, and this is one of the things that Dr. Jin talked about last week, that can be complications with some remote sensing data. A whole lot of shading happening here, right? Where we had some overcast cloud cover that happened, which makes some things more complicated. If we start picking out some of these different index values in these softwares that we can use, we kind of effectively eliminated that shading problem. And you could start picking out the soybean rows a whole lot more and figure out which plots have higher chlorophyll contents, have higher growth patterns with the soybeans, even at this early stage around V1 to V2. Okay. So again, just some really cool opportunities here, I think, to pick out various things very quickly, because with this, with the Mavic 3 drone that I was using in this, I could fly these areas in about 15 minutes, you know, and cover it with one battery life. That's a big deal, especially if we start talking commercial consultants and agronomists and things. Now, on top of that, I talked a lot about basically ID and herbicide injury there. We can also do the counter aspect of this and not worry about the crop. We just completely eliminate the crop out of the imagery, and we start detecting the weeds specifically to hopefully do various things. So once again, this was the initial image, the RGB image, and I just wanted to match up that when I started playing with the settings on what I was looking for at the bottom, I effectively eliminated out all of the crop, and I've just got where our hotspot patches of weeds are. Now, not 100% accurate by any means. I mean, like this is an example where you barely caught anything, whereas there's a pretty good patch of weeds right there. So I'm not trying to say this is an end-all be-all answer either. But again, for some growers and consultants and things that are trying to get some rough answers out there, or even from a research standpoint, if we're trying to figure out where some hotspots are for projects, or just about, you know, what kind of biomass do you think we're dealing with, this can be a tool again to give us some quantitative numbers in a quick fashion. I also will say one of the things going back to the see and spray systems that have been a big challenge for applicators using that is they often question, well, how much do I mix if I don't know how much I'm going to spray, right? This might be an opportunity where they could fly it, get a rough estimate at least that, oh, I'm probably going to have about 50% of the area covered in weeds. I'll mix for 50 to 55 to 60% of the field. And it gives them a better judgment call on how much to be mixed, how much spray solution to be mixing for certain fields. Okay. All right. Then with that, the other cool thing that I wanted to mention where we're already at with some of this precision technology is basically creating our own do-it-yourself prescription spray methods from some drone imagery technology. Right. So I'm just going to walk you through it because I think it's kind of cool to see it in action. Even though I can't show the actual program, I've got some screenshots to show you. So this is just an image that we took again in a trial this year up in Francisville. And I wanted to just play with it and see if I could detect where the weeds were at to spit out my own prescription map. So the pink is the border that I set up. So this is the field that I'm concerned with. Once you go through this magic tool, again, it's in this Pix4D program. It has an AI algorithm automatically built into it that you basically tell it the things that you want to keep and the things you don't want to keep in the image. Simple as that. So all the blue circles on here are the things I told it to keep, which is when I zoomed into those pixels, those are the weeds, right? And then I started highlighting, okay, the yellows I want to get rid of. I don't want to keep soybean plants. I don't want to keep bare ground, right? I want to get rid of all of that, so I'm not spraying any of that. And in this example, all I did was I selected 22 cells in that entire image. 22 cells. 10 I kept, 12 I got rid of. And from that, I was able to spit out this map right here, where it literally picked out, I won't say all, but it picked out a bunch of the weeds, and again, a lot of the hot spots where they were at, to create a prescription map of here's where you need to go target. From there, it allows you to add a buffer, because we all want to have a little bit of, error potential, right? So you add a buffer to it. So I did that. And then even at that point, even after I added a buffer around all of those areas that it detected, when it spits out to the very end here, it'll tell you your total area within the field, but then the total area that is going to be applied. And so in this instance, when I did this little demonstration, I had about a 50% savings. It went from about a 2.5 acre field down to about a 1.2 acre area that I was going to spray. That's pretty neat. And this whole process took me about 10 minutes to do. I'm all about user friendly when it comes to any of this stuff, right? So about 10 minutes, I was able to spit that whole process out, which is really, really nice. Now, the downside is, and some of the things that we have to test on the back end is, how effective is this prescription map when we start running it through various systems? And also, the accuracy was variable, not going to lie, okay? So if you look at this zoomed in image, here you'll notice a whole lot of purple where it's going to be spraying, and there's not a lot of weeds in that area there, right? And then also, if you come right over here, there's a ginormous weed right there that it didn't pick up and it missed. So by all means, not 100% accurate. It needs to be fine-tuned. But the other thing with that AI tool is it has the ability to learn. It gives you the option that you can check the box and it will learn from your selections and do a machine learning approach in the background. So if you did this enough, you could probably train it to pick out exactly what you want and be a whole lot more effective. Okay. Yeah.
That's farmer tolerance to weeds. It's more than just machines, right?
Right, exactly.
This is what we expect in control. So I'm gonna have to expect some escapes.
Yes.
I can't oversell this as what, I mean, you're.
Right. Well, and I think that's with, excuse me, I think that's with any technology at this point. It's any one technology by itself is not going to be 100% effective. And so it's putting together all of the pieces that can get us there, but you got to put them together and not just rely on one thing, whether it's a piece of precision equipment, machine learning, AI, et cetera, or whether it's, the old herbicide adage. Okay. All right, with that being said, oh, sorry, let me back up 1 second. With that being said, this prescription map can be spit out in numerous aspects, which is pretty cool. So you can spit it out to go to a spray drone and export it to an XAG spray drone or DJI spray drone, and a drone can go spray it, which you'll see we'll talk about in a second. Or you can also just spit it out into a shape file, and that shape file can be plugged into pretty well just about any standard ground sprayer now at this point that has the pulse width modulation. So the solenoid valves at each nozzle that you can precisely apply, which is a lot of our sprayers now. You can spit this prescription map out and make your own do-it-yourself prescription map sprayer with a lot of the technology that's already currently available. So this makes something like this a whole lot more feasible, again, to growers, rather than having to spend $500,000 to $1 million on a piece of equipment. You have about a $2,000 subscription fee or so for Pix4D, and everything else just runs on the equipment you already have. But with that being said, that runs into the whole spray drone conversation, though. I'm not going to spend a lot of time on this. But there are a lot of question marks in this world, this technology in the weed science world right now too, as well as in the plant pathology world. Don't worry, Darcy, I won't leave you out. But so there's a lot of question marks on how effective these can be, whether they're, they have a fit, whether we can control weeds and other things like that. So just a little bit of research that's been done on this. And Hunter back there is our expert drone graduate student, right? Okay, solid. But so this was actually, I stole that video from his project this year, but this is actually a project that we did down in Arkansas last year. And we were just looking at the weed control from a drone at 2 and 5 gallons per acre, comparing it to a standard ground rig at 10 gallons per acre, just to see if it had any merit at all, if it could stand up on its legs and be effective. I'll admit, I was trying to make spray drones fail when I set this experiment up. Okay, so I gave it a contact herbicide, paraquat, which is notorious for needing higher spray volume, better coverage, things like that. I put it at a low rate, and then at the low 2 GPA, I'm like, we're going to make this fail, and that'll be the end of the conversation. Well, it actually somewhat worked a little bit, and so now we've got to deep dive into more research. I guess that's job security, more research opportunities for the future. But the yellow boxes were the 2 GPA treatment that you can see there. The blue boxes were 5 GPA from the drone. Maybe a slight difference between those two, but honestly not a whole lot. And then the black boxes are the 10 GPA treatment, and it's really tough to pick out, particularly between the 5 and the 10, any differences visually there. If we look at some of the numbers, if we look at 1 week after we applied ratings, the 10 and the 5 GPA treatment, so the drone at 5 versus the ground rig at 10, no difference in weed control. The 2 GPA lagged behind a little bit, but not a terrible amount, but lagged behind a little bit. At 4 week after visual ratings, again, same story, 5 and 10 GPA were identical. The 2 GPA lagged behind a little bit, but not terribly much. But if we get out of visual ratings and we do some quantitative assessments, the weed biomass at the end of the 4 weeks was statistically similar. We had the same biomass across all treatments. The Vary, which is another remote sensing index using an RGB camera, so it's basically a measure of greenness of the plots, is effectively what that was, showed at 1 week it somewhat matched up with our visual ratings, where we had about 75% or so greenness, reduction in greenness for 5 and 10, and that 2 GPA lagged behind just a little bit. So that kind of matched up with our visual ratings. But then that greenness index matched up almost identical with our biomass data 4 weeks after an application. So what all of that tells me, right, is that sometimes our eyes can be a little bit deceiving when it comes to doing visual ratings, which makes sense. But also what it tells me is it looks like there may be something to 2 GPA with weed control. Maybe something. There's still complications here, but it's more feasible than I originally estimated with trying to make spray drones work from a weed control standpoint, even with a product like paraquat, which is a major contact herbicide. Okay? Now, the complication we just talked about, though, is the fact of the swath width, okay, and where this spray is actually landing on the ground and what's expected. So these were some of those treatments. We did this work here at Purdue, but this matched up with that study in Arkansas. So we had an XR flat fan nozzle, which is a fine spray at 2 GPA and 5 GPA. And then we had a twin fan, a TADF, which was a larger droplet size, like a very coarse, extremely coarse at 2 and 5 GPA. Does anybody notice a problem with those swaths? So this is dead center. The spray drone flew right down through these. We have 15 feet to the left and 15 feet to the right, and we were supposed to have a 20-foot swath. That's what we told the system. It should be 20 feet wide. Problem is that every one of these systems did something different, basically, for what that swath was, right? So the XR at 2 GPA, we basically almost have a full 30-foot swath. When we slowed the drone down to get to 5 GPA, because that's how we got to that rate, is we just slowed it down. It basically forced all of that spray into the center rather than spread it out. And so now we only have about, was that roughly a 12-foot swath? And it's also not centered. It got shifted slightly because of, a little bit of a wind direction. If we went to a larger droplet size, slowing down didn't matter as much for the GPA, but the larger droplet size did the same thing here and all funneled into the middle. And that also did not get us our full 20-foot swath width. We ended up with only about a 10 to 12-foot swath. That becomes problematic from multiple standpoints. If we're doing an entire field broadcast, we're going to streak it. With this shift in the direct center of where things are getting happen, if we're doing the targeted approach, that also becomes a problem because now where do you fly to target apply to those different weeds or those patches? Because you're probably going to miss some areas if that spray is shifting. So still a lot of research to be done on the spray drone front too. Some potential, but a lot of kinks to be worked out.
How about keeping the same height as you're flying?
So that with this one, another good question. With this one, we kept the same height at all times. It was always 8 foot for our study. Some people fly at 10, 12. It varies a little bit. Anywhere between 10 to 15 is common. Normally, if you keep the same height, like we did here, you'll still see this effect. If you start changing the height, this effect will change. So at the end of the day, to find the right answers, it's going to be a combination of messing with all of those things to get the correct swap. But no one has that answer right now on where you need to move your height to and what the swath should be and everything.
The one problem that we had at the beginning was that we thought, since we have programmed the drones to fly at a specific height, we started seeing that the thing started to drop.
Yeah.
Elevate and come back.
Yeah.
And so, but there are ways on how you can fix that if that's an issue.
One, excuse me, some of the older spray drones we've noticed have that problem a lot where they drift a lot in height. Some of the newer ones seem to have better radar capabilities now. They've upgraded that. And so they're holding their height a little bit better. So I had some conversations where like the new T50s from DJI have a much better radar sensor that they're able to keep that height a whole lot better.
And having a ground station helps a lot too.
Yes. Yeah.
So,
You know, so I mean, it's all variable, right? Everything is a new variable when it comes to those things. So,
that's all good.
yeah. Awesome. All right. With that being said, that's kind of the research tools part that I wanted to talk about today. Are there any questions on that front? All right. As a three-way appointment guy, I'd be remiss if I did not talk about the teaching and extension side, at least a little bit when it comes to some of these digital tools as well, right? So I wanted to highlight just a couple of things. It's not a lot, but a couple of things that we can be using some of these tools on that front as well. So one of the things I wanted to briefly talk about is this summer I did a study evaluating some of the free public AI chatbots and how well they were at identifying weed species, right? Like every county extension agent or extension specialist gets all these images and they have to try and ID those weeds from that image. Can these AI tools replace us, right, and do their job? So with the weed identification, I should say I tested these 4 free ones available out there. So ChatGPT, Gemini, U, and iNaturalist. And I just used the free versions. I didn't pay for anything. I just wanted to see if someone wanted to test them and get the result. So this table up here shows the results from a weed identification standpoint. I ran 104 different pictures of weeds through the system. The one takeaway that I got was that iNaturalist is actually pretty decent. Right, so I broke it down into various categories on whether it was 100% correct, it nailed it. If it was completely wrong with what it told me, if the initial guess was wrong, but it threw out a couple alternatives and that was right. If there was no answer at all, it just gave up and said, I don't know. Or if it kind of got it down to a genus or family, but didn't narrow it down to the exact species. That's kind of how I broke it all down. iNaturalist basically, it got roughly the right answer 82% of the time, whether it was the right genus or family, or whether it had an alternate that correct, or whether it was just correct right out of the gate. iNaturalist about 80% of the time gave us a near right answer. If you compare that to some of these other ones that are publicly available, it starts dropping off significantly as far as correct answers go. ChatGPT and Google Gemini were fairly equal. You just likes to give up a lot and says, I just don't know, which sometimes that may be the better answer, right, than giving me the complete wrong answer. So maybe not necessarily a bad thing, but a lot of these can't be trusted from an extension standpoint. And so one of the things I like to say is we still all have jobs as plant botanists and biologists, right, and extension personnel. We still need each one of us to be able to ID some of this stuff. But there's a lot of work that can be done on this front too with developing tools for the extension service to help better ID weeds. When it comes to herbicide injury, I also wanted to evaluate that on whether these different systems could ID herbicide injury. iNaturalist doesn't do that, so I had to drop that out. But I tested ChatGPT, Google Gemini, and U, and I only had 26 observations for this or images I fed in at this time. But what I was really pleasantly surprised with is ChatGPT almost knows what it's doing when it comes to herbicides. It was right about 73% of the time. And this one I have broken down into similar things here, except I would initially ask it, what site of action is this? So I'd give it a broad-based question first. If it got the site of action right, I would follow up and be like, okay, well, what specific herbicide caused this injury? And ChatGPT almost half the time was able to get the exact herbicide right, which I was pretty impressed with. And then the correct site of action was another 23% of the time. So it honestly did fairly well at ID and herbicide injury. Once again, was just like, I don't know, I give up. But the vast majority of the time, it didn't want to give me an answer. Again, maybe not always the worst case scenario though. Google Gemini was the massive disappointment from a weed science perspective. It only gave me the right answer about 30% of the time. I'm pretty sure a plant pathologist made Google Gemini because it wanted to give me plant pathology answers all the time. I'd ask it what herbicide symptomology caused this, and it'd be like, it's not a herbicide, it's this disease. I was like, oh, Darcy. So Google Gemini really showed. So basically the conclusion from all of this, once again, is we still need a person in the seat to handle a lot of these questions at this point. There's a lot of room for improvement on these things. But I also like to say that each one of these has its own kind of unique AI model that it's running in the background, and it'll give us some very stark, different answers for some of these things that we feed into it. So being careful from an extension and education standpoint is pretty critical there. One thing that I wanted to just kind of throw out there as an upcoming thing that we're doing is we're going to have an upcoming weed control technology survey to release to the public and try and gather a lot of different insights when it comes to these different technological pieces from a weed control standpoint. And I think some of these, questions and answers would be really beneficial for a wide variety of us in the room, because we're going to also ask things like, what is your internet service that you currently have available right now? What does your cellular signal look like? What's the capabilities for you to implement some of these different technologies with our, internet and cellular providers? What is your return on investment look like for some of these tools? How much what we want to spend on various things like that? So it's going to be weed control focused, but I feel that it'll have a lot of utility across the board for various other disciplines and extension personnel. So I just wanted to put a plug in for that we're releasing that this fall, winter, to try and gather some insights across the board there. And then just kind of finishing up, one of the last things I did want to mention is I did want to say a big thank you to the Purdue Weed Science team. One, for just welcoming me in, right, to the group and the team. I've enjoyed that a lot. I will also say too, this group, whether it's the row crop side of things with Dr. Brian Young and Bill Johnson and their crews, the hort side with Dr. Steve Myers, Dr. Aaron Patton on the turf grass side, everybody's reached out to me, wanted to do various things, bring me into the fold. And it's just been an awesome team to collaborate with. And every one of them is looking for answers from an extension and teaching standpoint across the board, which I really appreciate for all of this. So it's been a really important aspect of all of us, and it's been a cool team to be a part of. And so then the final thing, I never walk away without using another football reference, okay? If you take away nothing else from my presentation, here's a digital tool, right, that we can use on the extension and education standpoint with trying to make our points land home and get across. So my final message using some digital agriculture here is how we can get long-term successful weed control with these different tools. And so if we play the video, the first and foremost thing I like to mention is it's always going to start up front with the big boys of making sure we're starting clean and using full rate residual herbicides, right? We don't get away from that. We need to implement these other tools. We also need to do the little things in the background. We got to drop into coverage. Otherwise, the quarterback can just drop it off and it's an easy completion. So we got to do the little things right. But then where technology comes in and can play a really important role as we fly in off the edge here with the novel technology to smack those weeds, cause a fumble, and we follow up with integrated weed management. All of these things working together as a team to really provide long-term successful weed management strategies. Okay. I will tell you too, this was a tough find for Purdue football from last year. It's a very positive aspect. Anyway, that's my final conclusions. I just want to say thank you for coming today, and I'll take any questions.
Okay, who has questions for Tommy? I have several here if you don't. So to keep me from asking, go ahead, Fred.
Charlie, tell me on the, and I mispronounce it, Solon Tech.
Solon Tech.
Say it again.
It took me 3 months before I got it. So Solon F-Tech.
Solar head tech, how many gallons that thing hold? You remember what the tank capacity is?
It's got 2 tanks on it, like one on each side, just to balance it out. And I'm pretty sure total it's 40. I think it's 20 and 20.
That's all?
Yes.
And then to fill up, so it stops and a person has to come fill that thing up, right? I mean, it's not,
So
it doesn't go back somewhere to.
right now, at this moment in time, yeah, somebody has to go out and fill it, but they are already working on that it has an automated return. And basically they're automating everything on that front. Like they showed me a video of like their initial prototype where it will go back, it will like dock itself into a hose and everything, coupler, and it will then fill itself. So they're not there yet, but they're working on that part. Yep.
Don't they have an autonomous tender too that goes to it in the field?
Not this summer, at least, in the ones I was doing. Whenever I was
I
out
hear they're
there, they
working
were
on it,
running,
yeah.
but they might be working on it. But
Yeah.
right now, they were out there running to fill it up themselves. Yeah. Yeah, Darcy.
So on that aspect, legally, does someone have to be in the field though with the pesticide being applied for safety?
That's a question for Fred. I don't know.
I would think that would be the best, nobody's there.
Yeah, but I'm saying, yeah, but nobody's there to watch it have an error and I'm
Well-
guessing on pesticide law.
Yeah,
From a
and I don't,
pesticide standpoint, and also from the automation standpoint too, you may need to have a person there.
I don't know how, yeah, and I don't know how that would work with, so they have a system that ties into it that they literally will watch it as it's going. And it sends them all kinds of text message warnings and everything else. So not that that's foolproof for actually having somebody in the field, but I don't know where all of that would tie into the regulation side either. Like if you have enough fail safes like that, you know, if that satisfies some of that requirements, I'm not sure.
Don't our laws right now make you gotta have the pesticide, you gotta have the license on your pocket in the field when you're applying? How are they gonna, I guess that's my question.
That's a good question.
Or that
Right.
is something you think about. I mean, I think about the drones that are going out and they're not probably falling all over the spring.
Yeah,
So,
that's probably a good question for all these autonomous. Yeah, yeah.
What's your undergrad class that you said you had a triple appointment?
Yeah.
What's your class?
So I'm helping co-teach the Botany 505 right now, the
Okay.
advanced weed biology and ecology.
Okay, that's with Brian.
No, it's me and Bill Johnson and Kevin Gibson.
Oh, okay.
Yeah.
Good.
Yep.
Other questions?
No,
Who are you?
don't let him.
Okay,
So we don't use economic thresholds very much in weed management, for a couple of reasons. One, they're hard to estimate, you know, on an entire field site. And then also, we've had effective tools that we could just go kill it and don't worry about the cost. It's gonna be cheaper than what the weeds are gonna do. But we're coming to the point where that might not be as easily done. You don't have the herbicide that kills everything for under $5 an acre anymore. So we always talk about, you know, number of giant ragweed plants per unit area. Do you think we could do better with economic thresholds using some of the, you know, some of the things that you have shown, like the biomass especially? You know, we have a biomass estimate now of weeds in that field. Should we go control, will that protect our yield?
So I'll start off with, can we do better with economic thresholds? One, I would say yes, because we're starting at 0 basically, so it's only up from there. But so I think, yes, we could try and implement some economic thresholds more to some extent. I will say, in my opinion, they'll never be as effective or as useful from a weed management standpoint than like in some of the other disciplines, simply because of one like seed bank longevity and things like that. Like it's just not the same of like insect populations that, you know, winter kill or diseases that have variable, you know, life cycles and things like that. Our weeds are relatively, they're consistent. So it's a lot tougher to build an economic threshold model for reducing seed bank or factoring in the seed bank additions and subtractions and things like that. And also, like you mentioned, the biomass part. To me, I would almost think like the growth stage or the life stage of the weed would almost be more important than necessarily the biomass part, because as things get more towards the reproductive stage, more than likely we're for sure not going to kill it at that point. It's probably going to lose a lot of effectiveness for our different strategies, things like that. So I think we'd have to play around with what the actual useful parameter is in there, right? Whether it's height, biomass, growth stage, whatever else it is kind of thing. So I think there's opportunities, but I think it's going to be, again, another tool in the toolbox, but we got to use other things with it, if that makes sense.
I think it's interesting that the two companies you talked about, that with the automation and the artificial intelligence to control weeds, the Solix or Solentech, and then John Deere, they're both equipment companies. And so what do you see happening with crop protection companies like are Bayer and others wanting to get in there so they can reduce their herbicide sales? Yes, I'm asking a loaded question.
So, yes, what I'll say is that some of those companies have already tried to enter the market a little bit. So one example is One Smart Spray is a combination event between BASF and Bosch. And so they are already trying to work at a selective spray like that, targeted approach.
Okay.
There are a lot of these different manufacturers as well that are trying to conduct some research with their herbicides, with the systems. So they're interested in it. I think everybody, including the equipment manufacturers, though, are trying to figure out what their business model is going to look like for the next 10 years if this stuff does take off. So the equipment manufacturers are trying to figure out the subscription fees and the cost of equipment and all of that. The chemical companies then are trying to figure out, well, what do we need to charge on the chemical front? How do we create business partnerships to make some of this more feasible? So I would say everybody is interested and involved, and it's more of how do these business models shape up in the next 10 years?
Are there any ag retailers now going with a model that you could envision like, okay, so farmer, you pay me $40 an acre and I'll choose all the options. Some of it might be mechanical, some of it might be technology, some of it might be herbicide. Is there any of that happening?
I would not say holistically,
Yeah.
because like if we start talking, say, cover crops or tillage or, some of those other integrated weed management strategies we talked about, normally that comes down to the farmer, right?
Yeah.
The retailers and businesses are more or less, we can provide the drones as a service, or we can provide, maybe do some of the herbicide recommendation selections, and we can do this see and spray versus non-see and spray, or various things like that. But if you're talking holistically on the weed control front, I know of very few that really truly put everything into one basket for a grower at the end of the day.
Any final question? If not, let's give Tommy another hand.